This is Mr. Smith here, Section 5.4, Factoring Polynomials. There is one reason we want to be able to factor, and that is to be able to solve. Our end goal is to be able to solve polynomial equations. We're going to use factoring to do it. And generally we have this nice little property that says if A times B equals 0, then A equals 0, or B equals 0. We refer to this as the zero product property. It's going to be the foundation for our factoring approach. And the other thing to see is that it works if I introduce a third variable that doesn't matter and C equals 0. Okay, so we can have as many factors, we can set each piece equal to 0, and we can press on. These are some things we saw in Chapter 4. If I may draw your attention to the bottom two, difference of two squares. Difference of two squares, 9x squared minus 1 does factor. And if I again have two terms on the one below it, I can common term factor. Common term factoring is the first type of factoring we should always do. Common term factoring is the first type of factoring we should always do. And our goal now, our objective, is to make sure that we are factoring completely. Okay, we need to be able to factor completely. And so on previous quizzes, I took off some points because, and it would say you didn't factor this completely. We need to be able to factor completely, and this is a great example of how. Okay, look, 3x times x squared minus 4, this is not factored completely because x squared minus 4 factors to x plus 2x minus 2. Okay, so when we factor, we need to be able to factor all the way down. As much as we can factor, we need to do. Okay, so here are a couple examples. Here are a couple problems for us. So, the first problem, I see that every term has an x value in it. So I can factor out an x. Okay, so that gives us x squared plus 2x minus 15. Okay. So all I've done is I've common term factored, pulled out an x. At this point, we look to see, does the trinomial factor more? Can it factor farther? The answer is yes. So we factor farther. X plus 5, x minus 3. And now that is factored completely. Okay. I know some of you were happy that you had left factoring behind. I'm sorry, but it's here to stay at least throughout this chapter. All right, problem B. First type of factoring we always want to do. Common term factoring. So we're going to look through and pull out a common term. So both terms are even, so they'll pull out a 2. And this has a y cubed, this has a y cubed, so we'll pull out a y cubed. So this is 2y cubed. And now if I pull a 2y cubed out of 2y to the 5th, it should leave me y squared. If I pull a 2y cubed out of 18y cubed, it should leave me minus 9. It's 2y cubed. And now y squared minus 9 still factors. So we must factor it. That's what we mean when we say factor completely. So y squared minus 9 factors to y minus 3, y plus 3. Okay, last problem. We factor common term factor of 4z squared. That leaves us with z squared minus 4 plus 4. Sorry, z squared minus 4z plus 4. And now we look to see if that factors more. And so maybe we go z and z. How about minus and minus and 2 and 2? All right, that's my guess. Remember, my general prescription for factoring is a guess and check approach. Guess and check. So I'm going to try this z minus 2, and I'm going to see, does it get me back to here? The answer is yes. So then it's factored correctly, and at this point, completely. The only thing I'd ask is that we rewrite z minus 2 as 4z squared, z minus 2 squared. Okay. Are there any questions? I'll go ahead and record these. Anyone have any questions? I know I went through these quickly. Okay. Seeing none, let's press on. We're going to keep doing some more examples. So there's a special type of factoring that we're going to introduce in this chapter. And this you won't see very often. I'm not going to overwhelm you with this idea. I have plenty of other ideas I'll overwhelm you with. Okay. But here it is. If I have a cubed plus b cubed, that factors. Okay. In the same way, a cubed minus b cubed also factors. So if I can rewrite two terms as some number cubed plus some other number cubed, then it factors. Likewise, if I can rewrite two terms as some number cubed minus some number cubed, it factors. And you just have to memorize this formula for how it factors. Now, I realize it looks like there are two formulas. They're really identical if you ignore the signs. And I'll show you why you can do that. Okay? So look, you got a plus or minus b, b. Here you have a squared, ab, b squareds. Okay, so the formula is identical. A plus or minus b, a squared, ab, b squared. The only difference is the sign. And to remember the signs, it's as easy as remembering to use SOAP. That is, this sign will be the same. Whatever this sign was, in this case it's plus, this sign will be the same. This sign will be opposite. This sign will be always positive. Likewise, down here, if I'm subtracting two cubes, the signs will be the same, the opposite, and always positive. Okay, so now that'll help you to remember how the signs work. All you have to remember is this a squared, ab, b squared. Okay. And the last part of this is we're going to have to rewrite. So look at the example here. We're going to have to rewrite the first term as something cubed. And we're going to have to rewrite the last term as something cubed. Now in this case, 27 is kind of easy to see that it's 3 cubed. I think most of you could see that comfortably. But we also have to see that 8x cubed can be written as the quantity 2x cubed. So we have to actually spend an effort identifying what is A and what is B. Right? If I'm to use this formula, I have to know what A and B are. And so to do that, I stop and I identify that at the very beginning of the problem. Okay, so here we go. Here are two problems that utilize this idea. So, I need to write this as some number cubed plus some other number cubed. For us to use this formula, I need to rewrite this as some number cubed plus some other number cubed. Well, the first term is very easy. X cubed is x cubed, and so this will be A. A in this case will just be x. But what cubed is 64? Good. 4. Right, so this is just going to be a 4. And so that tells me A is right here, it's x, and B is just the value 4. And now I can apply the formula. And so the formula says, and maybe I'll try to squeeze it in over here. It says A plus B, so x plus 4, equals, or sorry, x plus 4 times a squared, so x squared, minus 4x plus b squared, which should be 16. And that is how that factors. Okay. That trinomial on the right-hand side will not factor ever more. We'll never be able to factor that trinomial more. You don't have to worry about that. So, if you are factoring a trinomial, if we are factoring a sum or difference of cubes, if we're factoring a sum or difference of cubes, we just need to memorize a formula that tells us how they factor. And the formula is on the previous slide. Okay. Let's take a look at part B. Now remember, I need to write this as a cubed minus b cubed, except well, I got z to the fifth, I got z squared. What's going on there? Oh, that's right. What's the first type of factoring I need to do? I got to do common term factoring. Okay, so it's common term factor. We can pull a 2z squared out. That gives me 8z cubed minus 125. Ah, that's better, right? Now I see cubes, I see 125, which is something cubed. Okay, that looks a little better. So, again though, let me write this 2z squared. And I need to write this, I need to rewrite this binomial here as something cubed minus something else cubed. All right, for us to implement the formula, I have to know what a and b are. So let's start here with 125. What cubed is 125? Should just be 5. That's not bad. All right, 5 cubed is 125. That part's easy. But what about this? 8z cubed. So I know I should have a z here, but right, because z cubed will give me z cubed. But how do I rewrite the 2 as something cubed? Or sorry, the 8 as something cubed. Right? And I gave it away. Spoiler alert, I gave you the ending. Right? This is just a 2 here. I need to rewrite 8z cubed as some quantity cubed. Right? Because that's what the formula tells me. I have to have a, and I need to know what a is, and I have to have b, and I need to know what b is. And so I rewrite 8z cubed as 2z quantity cubed, and these two are equivalent. And now I can simply apply the formula as we saw it on the previous slide. Don't forget about our leading term here, 2z squared. And now this will factor to 2z minus 5, a minus b, and then times a squared, so 4z squared, plus 10z, and then plus b squared, which in this case is 25. Okay. And that is factored completely. And that would be, at the most, what I would ask of you at this level. Okay. I expect you to know this formula. I do expect you to have it memorized. I will not bludgeon you with it. Okay. Yeah, so I would consider this a special type of factoring. That is the sum or difference. Right, we have a difference here of 2 cubes. Here we have a sum of 2 cubes. So in that, I would say that you wouldn't see this very often to begin with. But if you do, you should know that it factors more. Okay. All right, so I'd like you to look here at problem number 2. Problem number 2 has 4 terms. We should always look to see if we can common term factor. No, we can't. Can't do that. It's not a trinomial, so our standard form of factoring is not going to work. It's obviously not the sum or difference of cubes, so that's not going to work. So we introduce a method in Algebra 1 to deal with 4 terms. It's called factor by grouping. Factor by grouping basically starts out by saying you take the first 2 terms and you put parentheses around them. You take the second 2 terms and put parentheses around them. Why that is, it's just factor by grouping. That's how we start the procedure. Okay. Now, we have to be careful that we do not change the original problem. To be careful that we do not change the original problem. So, by me adding parentheses to the first 2 terms, did it change the original problem? Right? I got x cubed, start with x cubed. 2x squared, 2x squared. I'm good. What about the second 2 terms? Right? Here this minus gets distributed. Minus gets distributed, and this becomes negative 25x, but it was originally negative 25x, so that's not a problem. However, this minus sign, when it gets distributed now, this turns into a plus, but it wasn't originally plus 50. It was originally minus 50. So by me adding the parentheses, which is what I have to do, I've inadvertently changed the problem. We don't want to change the problem. So I need some fix, because I got to put the parentheses in, but I don't want to change the problem. So I need to do something to not change the problem. Go ahead. That's right. So if I simply change this sign after adding the parentheses to plus 50, which seems a little counterintuitive, right? We're changing the problem so as to not change the problem. But that's exactly what we're doing, right? Now when I distribute the minus sign, it becomes minus 50 again, which was what the original problem said. That's what we need to do here. You will only have to do this if it's subtraction in the middle. Let me say that again. You will only have to do that correction if it's subtraction in the middle. If it's addition in the middle, you won't have to deal with that. Okay. Just a caution, and now we proceed. So factor by grouping proceeds by factoring each set of parentheses. So look here. Is there anything that factors out of this? Well, yes, there is. All right, I can pull out an x squared, and that leaves me x plus 2. Look at the second set. Is there anything that factors out of there? Well, yes, there is. I can pull out a 25. So that leaves me also x plus 2. Okay, so all I've done is step 1, I threw in parentheses. Step 2, I made a slight modification so as to not change the problem. Step 3, I common term factored within each set of parentheses. Step 4, each term, here's the first term, here's the second term, and each term has an x plus 2 in it. Each term has an x plus 2 in it, so I shall factor that out. So if I pull out an x plus 2 out of the first term, what does it leave me with? Well, the only other thing in the first term was the x squared. If I pull an x plus 2 out of the second term, what does it leave me with? The only thing here would be left would be a minus 25. And that is the idea of factor by grouping. Now, we're not finished. Not finished. But I want to go back through the steps one more time. Step 1, we throw in parentheses. Step 2, we modified the sign because it was subtraction here so as to not change the original problem. Step 3, we common term factored within each set of parentheses. Step 4, I pull out the x plus 2 out of both terms. Leaves me with an x squared minus 25. And our last step, x squared minus 25 factors into x plus 5, x minus 5. X plus 5, x minus 5. And now that is completely factored. Again, if you struggled with factoring before, it's only going to get compounded. We need to go back through and make sure you can factor pretty well. Okay, so the question is, why do we pull the x plus 2 out, right? So from this step to this step. Yeah. So let me rewrite this, maybe to help you see it a little better. So I'm going to rewrite x plus 2, and I'll call it a. So what I have here, if I rewrite this, I have x squared times a minus 25 times A. But now A is common in both terms, right? So let's factor A out, right? There's an A here, there's an A here, so pull out the A, but then what's left? X squared minus 25. Okay, and of course A was our example of X plus 2. Okay, that's the idea. It's a little difficult to see, I recognize. All right. Let us finish off with this problem. Let's finish off with this problem. So, this is a fourth degree equation. We never saw fourth degree equations before. By the time you leave my class today, you will have. So, I'm going to set this equal to 0. So, x to the fourth minus 10x squared plus 9 equals 0. By the way, class, how many solutions do you think might be here? Just go out on a limb. Yeah? 4. Maybe. We'll see. Okay, so I'll show you two approaches. Number one, we're going to just factor this. Now, we're not used to factoring things like this, but I promise it'll feel very familiar. What do you think I should use as the multiples of x to the fourth? X squared and x squared. Seems pretty reasonable. What about my signs? What do my signs have to be? How about minus and minus? And factors of 9, 3 and 3, 9 and 1. Now 3 and 3 are not going to give me 10 in the middle, so how about 9 and 1? And that works. That works. But now each of these factors more. So x minus 3, x plus 3, x minus 1, x plus 1 equals 0. And lo and behold, I see there are 4 solutions. X equals plus minus 3, x equals plus minus 1. Welcome to polynomial equation solving. Right, this is a major thrust of Chapter 5. I want to show one other approach, one other way to visualize or approach this problem. And that is to make a substitution. And so I'm going to use the letter u, and I'm going to let u represent x squared. Okay. So every x squared in that function, I'll rewrite it as a u. Okay. So on the right-hand side of the equation, I get equals 10u. And then I get 9 plus, but now how do I write x to the fourth in terms of u? Right, I don't want to have u's and x's. Don't do that. That will make your life miserable. I just want to have u's here. So how can I rewrite x to the fourth in terms of u? And the answer is u squared. Right? U squared. If you don't believe me, let me just put it down here. If x squared squared, right, equals x to the fourth, x squared squared equals x to the fourth. And of course, I'm letting x squared be u. So this is just u squared equals x to the fourth. So look at what I have over there. On the right-hand side, I see I have u squared plus 9 equals 10u. So we could go u squared minus 10u plus 9 equals 0. That's a quadratic equation. We know how to solve quadratic equations. We have the quadratic formula. If you finish this, what you'll get is u equals 9 or u equals 1. Right, but remember, we made a substitution. So what we're really saying is that x squared equals 9 and x squared equals 1. And that should allow you to find your 4 answers. Right? We take the square root of 9 plus minus 3, square root of 1 plus minus 1. Okay. So this concludes the lesson for section 5.4. Thanks for your attention. Good luck on the homework.